Hello, my name is Julien Lepiller, and this presentation is about the analysis of infrastructure as code to prevent intra-update sniping vulnerabilities. Infrastructure as code is a relatively new way to manage your infrastructure. Most recent applications require you to deploy multiple instances of the application, and you might need to manage even more servers, such as multiple databases or a reverse proxy to manage the load of your application, etc. Of course, you can always manage all of these servers individually by connecting to them and managing your configuration. However, you could use infrastructure as code to describe this infrastructure and all of their server, their configuration, where they are deployed, etc., and let infrastructure as code tools update your servers for you. However, during these upgrades, you might actually be vulnerable to a sniping vulnerability. To illustrate, let's take a very simple example. On the left, we have a simple infrastructure where we have a database in blue and a lambda in orange. This lambda is running some custom code on the cloud. It is connected to the database and it is returning the favorite food of users. In order to connect to the lambda, we add an API gateway in purple so that anyone on the internet can access the API and find the favorite food of the users. Now imagine you want to update this infrastructure, and instead of returning the favorite food of the user, you want to return some private information such as their address. To do that, you update the lambda to return this new information in this lambda 2, but because you're now returning private information, you also want to add a security layer. Adding this authorization layer in red ensures that only authorized users can access this information. This is safe in both cases because you return public information on the left and private information on the right, but only to authorized users. However, during the update, there are two possibilities. Either the lambda is updated first and then a security layer is added, or the security layer is added and then lambda is updated. In the first case, during the update, any user can access your API and exfiltrate the private information from your database. To fix that, you can add explicit dependencies to your infrastructure. In this example, you need to add an explicit dependency that says the lambda depends on the security layer. So in this case, the lambda is not updated until the security layer is added. However, in reality, there might be hundreds of different resources in your deployments, and there are many dependencies that users need to check, so it is very error-prone. We have managed to reproduce this vulnerability in AWS and Google Cloud, and Google, for instance, told us that they do not consider this as a bug on their platform, but rather that users should know what they are doing. So we propose a tool, that is able to check for these vulnerabilities. Given an initial and target infrastructure, the tool is deriving a model that is a graph representation of the network request flowing in the infrastructure as well as the security of the infrastructure. Using this model, it computes the intended security of the initial and target deployments. It also computes an over-approximation of all the possible intermediate states, as also as a graph representing the network and security. Using this, the tool is able to compute the actual security during the deployment, and it is comparing the two to make sure that during the deployment all resources are at least as secure as intended. If it is the case, then the tool returns no error, and otherwise it will try to take dependencies into account and refine the over-approximation. But if there is no relevant dependencies, then it will report the warning to the user and propose a new dependency to add to fix this issue. We have evaluated the tool on 36 different files from public repositories on GitHub for a total of just under 1,000 different versions, and here I was able to run for under 1 second for each of them, which makes it really suitable for being integrated before a deployment to the cloud or in users' pipelines, such as in continuous integration systems.